I'd like to start off this video by giving you a quick warm-up. Hopefully these questions are pretty easy. Go ahead, pause the video and try them out. You don't need to actually write down the problem. Okay, so hopefully you got that the derivative of all three of these was 2x. And I want you to keep in mind that there are many, in fact, infinitely many functions that will have the same derivatives. So keep that in your mind as you're going through this video. So today I'd like to talk about antiderivatives. So you might be able to guess what an antiderivative is just based on the name. We usually denote an antiderivative of a function f by using a capital letter F. Basically, what an antiderivative is going to be taking the derivative in the opposite direction. So the example that you have above with 2x, you'll notice that I actually have 3 antiderivatives of 2x. You're going to have an infinite number of antiderivatives. So all of those things, x squared minus 4, x squared plus 8, x squared plus 127.3, those are all antiderivatives of 2x. So basically, an antiderivative is what you get when you go in the opposite direction of taking the derivative. So because we say that there are an infinite number of antiderivatives, we will, if I'm asking you to take the antiderivative, we will write our answer with a plus an arbitrary constant. I'll show you what I mean. So we will write our general antiderivative as the antiderivative of your function plus a constant c. So let's do a few examples together. For the first one, we are finding the derivative of f. So we want I'm going to call it the capital F. We basically are looking for a function where if we were to take the derivative of that, we would get x squared. So if you think about using your power rule, when you do the power rule, you're going to move the power, the exponent forward, subtract 1 from the exponent, and put the exponent in front of your function. So we can tell right away that if you were to figure out the antiderivative, the exponent would be 1 more than the x squared. That's the first thing. If you were to take the derivative of x to the third, we would get 3x squared. So you have to be really careful about that. You want something that can cancel out that 3. So it's actually going to be 1/3 x cubed, or we sometimes write it as x cubed over 3. And then we write that as plus c. So you can go back and you can check your answer by just kind of remembering how to take the derivative of f of x, of capital F of x. And if you take the derivative of x to the third, you will, or 1/3 x to the third, you will get x squared, which is what you started with. If you take the derivative of a constant c, you get 0. So that also goes away. So this right here is my answer. For number 2, we're doing pretty much the same thing. So we have our function. This right here, the sine of x, is our derivative. We're finding the antiderivative, meaning we're figuring out what can you take the derivative of and get positive sine x. And if you take the derivative of cosine, you get negative sine x. So that's really close. So actually, our antiderivative is going to be negative cosine of x, because if we take the derivative of that, that will give us a positive sign. Don't forget to put your plus c. The last one, number 3, our derivative is 1 over x. The only function that has a derivative of 1 over x is actually going to be ln of x. And again, don't forget to put your plus c. So the next thing, it looks really, really complicated. Basically, if you want to find the derivative of anything to a power, you're just going to add 1 to the exponent, and whatever your new exponent is going to go on the bottom of the fraction. So, for example, if you have, I think we're on number 4, if you have x to the third, the antiderivative is going to be x to the fourth over 4 plus c. I spelled antiderivative wrong. Sorry about that. You can tell that that's the answer because if you were to take the derivative of x to the 4 over 4, you would get x to the third. So just kind of keep that in mind. You're going to do so many of those that you'll probably eventually start doing it automatically. So let's do an example that's a little bit harder. So for this example, we are going to find a function given the derivative of the function. So that means that we're finding the antiderivative of this function right here. So let's do it one piece at a time. The first thing we have, 4 secant squared x. 4 is a constant, that's just going to stay in the front. The secant squared x looks really, really hard, but if you remember that the derivative of tangent is secant squared x, that'll help you a lot. X to the fifth is one of those powers, so we're actually going to add 1 to the exponent and then divide by whatever our new answer is. For the third part of this, I think the easiest way to do this one is the same way as when you had derivatives. We're going to rewrite this in exponential form. So we have, first of all, the x squared, the cube root of x squared is on the bottom of the fraction, so it's going to have a negative exponent. Cube root of something squared is the same as negative 2/3 as the exponent. So you need to do a little bit of simplification first. Once you have that, we keep our 4 in front. Remember, a coefficient of something is going to stay the same. What we're going to do now is we're going to take our x to the negative 2/3. We add 1 to that, so negative 2/3 plus 1 is 1/3. Then we're going to divide by our new exponent. Our new exponent is 1/3. So I'm going to simplify that out. My final answer now is going to be 4 tangent of x plus x to the 6 over 6 plus 12 x to the 1/3. You can also write that as the cube root of x. Either way is okay though. And actually, I almost forgot something that I had just told you about. Don't forget to put your plus c. So you will need that. I'm going to show you an example right now where you actually are going to use that. So for this next problem, we are finding the antiderivative. However, I've also given you a, we call this an initial value. Initial value means that we're going to start with, we know that when x is 0, our y value is negative 2. And if you have a situation like that, that initial value, the f of 0, is going to help you find that constant c. So let's go ahead and do this problem. So first of all, we're going to find our f of x. The antiderivative of e to the x, you're going to like this one, is just e to the x. That one's not that bad. The antiderivative of 20 cosine x is going to be 20 sine x. And don't forget your plus c. Once you get to this part of the problem, on any problem when you're taking an antiderivative, I highly recommend looking at your answer, taking the derivative in your head to make sure that you get what you start with. It's really important that you do that. So I hope you didn't forget the plus c, because we are going to use that and we're going to actually find that answer. So we know that f of 0 is equal to negative 2. So that's going to give us that negative 2 is going to be equal to e to the 0 plus 20 sine of 0 plus c. Now we are going to solve this equation for c. So I get -2. Any power to the 0 is 1. Sine of 0 is going to actually be 0, so I end up getting 1 plus 0 plus c. And if I simplify it out, I get that c is equal to -3. By the way, I am not done with this problem. If you get this far, that's great, you get half credit, but you gotta go further. We are not finding c, we're finding f. Make sure you know what you're looking for in the end. So now my final answer is going to be f of x, and I'm just gonna take what I have up here, equals e to the x plus 20 sine x. I now know that my c is -3, so this right here is my answer.